So I'm going to talk mostly about mesenchymal stem cells, and I think Dr. Nocera covered the difference between embryonic and adult stem cells. And basically in Panama, we use umbilical cord mesenchymal cells. So as I said before, there's a live, healthy birth. There's the afterbirth. It's going to be thrown in the trash. We actually have done molecular screening on the cords that we get. We use less than 1 in 100 cords because we know, based on our clinical experience, we're in a unique position in that we've treated over 3,000 people, and we know which cells work and which cells don't work, so we're able to have a high throughput screening test that allows us to pick only the cells that we know are going to be the most useful for our patients. So what are the three things that mesenchymal stem cells do? Well, they help to control inflammation, they modulate the immune system, and they stimulate regeneration. And when I start talking about the different trials that we're doing, you think to yourself, wow, that seems like a spectrum from spinal cord injury to autism, for example. But you will find that there are those three things in common. Either there's a problem with inflammation, there's a problem with the immune system, or there's a problem with regeneration. And so most chronic diseases are due to either a lack of mesenchymal stem cells or a dysfunction of mesenchymal stem cells. And as we age, I think Dr. Nocera hit this on the head when he said, as we age, we not only lose the number of stem cells, we actually lose the homes for our stem cells. And I'll show you in a minute where our mesenchymal stem cells live in our body. So the cells have these benefits, but it's not because the cells are actually, in the work that we're doing, we're not looking for the cells to become another tissue. We're not looking for a cell to go in and become new heart tissue or to become new spinal cord tissue. What we're looking for is the secretions of the cells, and Dr. Nocera showed the cytokines being secreted by the cells. The secretions of the cells actually are what do all the heavy lifting. They're the ones that stimulate the regeneration, they decrease the inflammation, and they modulate the immune system. It's not the cells becoming other cells, and I'll give you examples of that. Arnie Kaplan is the father, or I call him the godfather. Every 2 years he has a meeting up in Cleveland. He's at the Cleveland Clinic. He actually named the mesenchymal stem cell. He's kind of backing away from that because of this, the mesenchymal stem cell, the reliance upon the secretions of the cells is more important than the cells themselves. We know that these cells can differentiate into other cell types, but really the important thing is these MSCs are acting more like medicinal signaling cells, and so he's kind of leaning towards that name now. Anyway, this is a cartoon that Dr. Kaplan made showing the different activities these medicinal signaling cells or mesenchymal stem cells have. They have effects on the immune system, all aspects of the immune system. They stimulate regeneration, they have anti-scarring effects, and they induce new blood vessel growth, which is really important because that's where these cells live, on our blood vessels. So if you want to repair any tissue, you have to induce new blood vessel growth in order for it to be completely healed. So where do these cells live? This is a picture this was taken from the body exhibit, which is the Chinese pathologist who got access to a whole lot of involuntary volunteers, I guess. And he was able to slice and dice, and in this case, this person after death, their blood was basically rubberized, so that all of their blood vessels were rubberized, and then they digested the rest of the body away. And these are the blood vessels of a human being, and this is where our mesenchymal stem cells live. This is a picture of a capillary, and a capillary is the smallest blood vessel in our bodies, and they're found everywhere in our bodies. And the pink colored cells are mesenchymal cells holding on to the capillaries. So they're literally found throughout our bodies. And the depressing thing is that with age, they decline. The happy thing is with younger cells, you can actually make your old cells behave like younger cells. because not only is there a decline in number, but there's a decline in the fitness of your cells. So your cells, just as we get sick, our cells can get sick. And we know that in people with lupus, people with multiple sclerosis, people with rheumatoid arthritis, if we take out their mesenchymal cells from their fat tissue, which is highly vascularized and therefore has a lot of mesenchymal cells in it, if we take it, those cells misbehave. They don't behave robustly. So there's a really depressing slide. So when you're a baby, on the left, that's the number of stem cells you have in your bone marrow. By the time you reach skeletal maturity, 90% of your stem cells are gone. Well, they went from you being a 7-pound baby to distributing throughout your body, and that's pretty much what we have to live on until we run out completely. I did want to acknowledge this, I'm going to get into our clinical trials here in a minute, but I wanted to acknowledge Dr. Van Strickland, who's here. He's sitting right over there. Say hi, Van. Dr. Strickland is doing the first trial of human umbilical cord mesenchymal cells in the United States that's ever been done. And he's doing it with our cells from Panama on one of our patients with Duchenne's muscular dystrophy who's been down there. He had been treated there 7 times, and the FDA gave us an IND, investigational new drug, and Dr. Strickland is the investigator on that. So Dr. Strickland is the first doctor in the United States to treat a human being with umbilical cord cells. Way to go, Dr. Strickland. Good. So one of the biggest problem with aging is we always have degeneration going on, and the good news is with stem cells we have regeneration going on. The biggest problem is as we age, that regenerative capacity decreases. And this slide shows you the doubling time of mesenchymal stem cells taken from a baby, from a 35-year-old and a 65-year-old. And from the baby, those cells divide every 24 hours. In a 35-year-old, they divide every 2 days or every 48 hours. In a 65-year-old, they divide every 60 hours. And it sounds pretty linear. Well, that makes sense. As you get older, it takes longer for those cells to divide. But if we take one cell from a baby and put it in the culture dish, and it divides every 24 hours, at the end of 1 month, we have 1 billion cells. If we take a 35-year-old with a 48-hour doubling time, we have 32,000 cells. If we take a 65-year-old, at the end of one depressing month, we have 200 cells. So if your degeneration is exceeding your regenerative capacity, then you're only going to go in one direction. So that's the biggest point of this, is to show you how precipitously with age our capacity, the capacity of our stem cells to regenerate, goes down. And it's more due to functionality than it is pure number, because when these cells want to fix something, you've got to have a critical mass of cells to fix it, or it never gets fixed. If you want to jump over a mountain and the mountain's 22,000 feet and you jump 20,000 feet, you're not going to get over the mountain. And so this is the main goal of what we're trying to do in Panama and here in Dallas with regenerative medicine, is to get you to 22,000 feet. Doesn't matter what condition you have, we need to use young, healthy cells to stimulate your cells to behave younger and healthier, divide more, and actually fix the problem. So this is a little bit about Metastem. We've been down there in Panama since 2007. We actually had a biotech company in the United States, and our major discovery was that we discovered that menstrual blood has mesenchymal stem cells in it, and we created a patent portfolio around that, and that company was subsequently sold last year. But we carry on doing our research in Panama mostly with the umbilical cord cells. We don't do any work with the menstrual cells. But we have six doctors on staff. We have 7 clinical trials going on right now. They're all on clinicaltrials.gov, which is the National Institutes of Health website database of clinical trials that are going on. So, and as I mentioned, Dr. Strickland, we have our first approval for U.S. use of our cells for Duchenne's muscular dystrophy. We've recently got the second IND for a young boy. So Ryan, the recipient and the subject in the first trial, is almost 30 years old. And you know, for Duchenne's, that's a pretty old patient. We have a young guy who's 5 years old, has been treated, and so far he's not needed any steroids, he's not needed any bracing, he's not needed any kind of standard treatment for Duchenne's, as long as he's treated every 6 months. So that IND has been approved in the U.S. as well. So we're making headway here, but slowly. So a lot of people ask me why we went to Panama. Well, in 2004, they passed a law in Panama, and the idea was to ban embryonic stem cell research. And so basically the first page of the law says, if you do embryonic stem cell research, if you treat human beings with embryonic stem cells, you're going to go to jail and you're paying a big fine. The second part of it was, if you use adult stem cells, including umbilical cord cells or stem cells from the patient's own blood or own fat, or any adult source of stem cells, you can do it as long as you do it under informed consent. So it was a very broad law that drew a certain number of folks interested in cell therapy to Panama, and me being one of them. So we're also in the City of Knowledge, which is the former U.S. Southern Command and Control for the U.S. Army. It's across the street from the canal. It's a tax-free zone, and we have also incentives. We can bring people in from anywhere in the world because we're in that technology park. We're allowed to bring people from far reaches of the world who are experts and to help us out to get to the next level. Anyway, if you haven't been to Panama recently, or even seen a picture of it, look it up. It's unbelievable. It looks like Miami. It's really a fantastic place to go. So just to give you a global perspective on the legal aspects of where we are, the last line is, in my mind, is the most important. The U.S. is being left behind. There are places like Japan has recently passed a regenerative medicine law that basically shortens the amount of time. Right now it takes this long and $800 million to $1.2 billion to get a drug approved in the United States, and they've shortened it for stem cell therapy in Japan. Once you prove safety of your product, you can go to market with your product. So in a few years, you can get a product to market for less than $10 million, whereas it's $1 billion in the United States. And there are other countries following suit. So Japan already has 3 cell products approved. South Korea has cell products approved for knee osteoarthritis. New Zealand and Canada have a couple products approved for graft versus host disease. But quickly on the heels of Japan, you now have South Korea has a bill in their legislature right now that's almost identical to the Japanese law. Taiwan is very close to introducing the same bill. We had a group in Mexico 2 weeks ago. Mexico is actually looking to pass a bill, and I think this is my little soapbox. In the United States, we need to get on this wagon, or we're going to be left way behind. And in Panama right now, the law is going towards the Japanese. We believe that there's going to be a Japanese type law in Panama as well. So the interest in mesenchymal stem cells, this is over the last, 50 years, and you can see this is just a search term on the National Library of Medicine for mesenchymal, and you can see the interest is logarithmic. These are the number of published articles. Just last year, there were over 8,000 articles published with that term mesenchymal in it. And this has all happened in the last 10 years. So these are the conditions that are being treated on. These are from clinicaltrials.gov. These are the conditions that are being treated right now globally. And these are the conditions that we are treating in Panama. We're treating multiple sclerosis. I'm going to introduce you to a patient who's been to Panama with multiple sclerosis here in a minute. We're doing a rheumatoid arthritis study. We're doing an autism study, and I'm going to introduce you to the father of a young man who's been there for treatment for autism. We're doing an osteoarthritis study, and we're also doing an asthma study. And They may sound disparate, but please remember that umbilical cord MSCs have these three properties. They inhibit inflammation. If you look at multiple sclerosis, rheumatoid arthritis, they're both autoimmune diseases with inflammatory components. Autism is really an inflammatory disease, and I'll talk more about that. Spinal cord injury is a lack of the ability of the body to regenerate itself. So if you think about it, we built evolutionarily, we built this wonderful cage around our spinal cord. We've spent so much evolutionarily on this spinal column to protect our spinal cord and our skull that we didn't put many mesenchymal stem cells on the other side of that cage. So if you introduce mesenchymal stem cells into that space, you can get regeneration. So osteoarthritis is both inflammatory and a lack of regeneration, and asthma is predominantly inflammatory, but also has an autoimmune component. So even though they sound disparate, they're all addressed by the activities of mesenchymal stem cells and the activities of the secretions of mesenchymal stem cells. So just, you know, we're not operating in a vacuum. We collaborate with a number of universities. Cook Medical, which is a global corporation, is our co-development partner for going forward with our clinical trials internationally. And like I said, we started our first clinical trial in September of last year. So we actually started his third treatment last month. So these cells are umbilical cord, and I think I've already covered this, but the main thing is that we have this selection process. Not only they're heavily screened for, the mother's screened, the actual cord blood itself is screened for any infectious disease. We have a very complete quality control process. We have an entire team, all they do is quality control. They're tested for sterility, endotoxin, and so the amount of testing, we have a 16,000 square foot laboratory. I'll show you some images of that. But we have a manufacturing facility that most people, when they come to Panama, they're floored when they come to our laboratory, because we're literally 200 feet away from primary rainforest, because this was carved out when when we built the canal, and then we built this military base to support the canal. They just cut right through the primary rainforest. So we're literally 200 feet away from primary rainforest, and we have this state-of-the-art facility for isolation and manufacture of umbilical cord MSCs. And here's the schematic of how that's done. The actual umbilical cord on the left, you can see that there's a vein and there's the arteries, and that we dissect that tissue, and then it's digested with some enzymes, and then the cells are free floating, and then they attach to plates, and then they're put in an appropriate growth medium, and they're grown up, and then we do all the quality control, and then they're frozen down in liquid nitrogen temperatures so that they don't have any activity, and they can be brought up, and the viability of them is very high when they come out. So as I mentioned before, we discovered the mesenchymal stem cell in menstrual blood, and this is the first four-color picture of one of those cells. And this is one of those. This is one of those cells dividing, and then this is the cells as they're attached. So they like to be attached. They're called anchorage dependent, meaning they have to hold on to something in order to divide, to grow. And then when they divide, they actually let go. So if I go back, the cells, it's all rounded up because it's let go. And these are different magnifications. This is the highest magnification. I'm going to talk about rheumatoid arthritis, which is predominantly an autoimmune condition. And then I'm going to talk about spinal cord injury as predominantly a lack of ability for regeneration. So this study was done in China. They used 172 subjects who had rheumatoid arthritis. They were already on anti-rheumatic drugs. That's what the DMARD stands for. Basically, they gave them a single infusion of 40 million umbilical cord MSCs, and all of them got better, and there were no severe side effects. Other than that, it wasn't very impressive. So how many people have heard of Humira? Enbrel. So these are heavily advertised medications, and they're anti-rheumatic drugs, and they're sold in the United States. They do about $14 billion a year. And what they do is they target TNF alpha, which is sort of a key player in the whole inflammatory process. And there's TNF alpha and another molecule called IL-6, and they're both kind of key players. And now IL-6 has a host of drugs that attack it. But here's the cool thing. With a single dose, the TNF alpha in these patients dropped by 50%. And then they did another cohort. They treated them again 3 months later, and their TNF alpha dropped a further 50%. So they got a 75% reduction after 2 doses of these cells. And here's the data. Basically at the top, you're showing those are clinical scores. You show that they improved. Down below, these are CRP, C-reactive protein, which is an inflammatory marker. It dropped. And then also rheumatoid factor, that dropped. And then here you show after the first treatment, these are quality of life scores. The top left is a quality of life, improved after 1 treatment, improved even further after second. The second one is a joint score that's done by the physician, improved again. And then the last slide there is showing the T regulatory cell, because that's the cell, that's kind of the master cell in your body, whether you have MS or rheumatoid arthritis, that tells the immune system to behave itself. And here's just some more data. But here, is there a light on this? Well, if T regulatory cells work right here. So normally, if we have something bad going on in our bodies, our T cells have to become activated and they have to attack it. And so what they do is they have to become activated, and then once they're activated, they start dividing. And as they divide, they build an army to hopefully attack whatever our problem is. Well, in the case of rheumatoid arthritis and multiple sclerosis, they're attacking tissues that don't need to be attacked. And what T regulatory cells do is they block, they block this activity right here. So these cells, it doesn't cause a dramatic immune suppression like steroids do. They selectively block this clonal, like it's called clonal expansion, basically this building of the army. So that's what we're trying to do with infusion of umbilical cord MSCs, is to upregulate this one motherly cell type that says to the rest of the immune system, it's okay, gives it a big hug, it's okay, you don't need to carry on doing this. And that's the premise for our work. So that's rheumatoid arthritis. I'm going to talk a little bit about spinal cord injury. And the main point here is that the cells are not becoming spinal cord tissue. The cells are secreting things that are stimulating the spinal cord to repair itself, because the spinal cord has a paucity of mesenchymal stem cells. Spinal cord is deficient in mesenchymal stem cells. So this is a rat study that was done probably 7, 8 years ago, and they cut the cords of the rats. And when you cut the cord spoings back, and so you have this gap in the middle. And then they took human umbilical cord MSCs, and they put them in a little fibrin glue to keep them in place, and they injected them in that gap. And this is a little cartoon showing they injected in the gap and then on the basically the dead ends of the spinal cord. And what happened was the spinal cord regrew. But the main thing that they found out was there's pictures that I could go through, but for time I'm not going to go through all the photographs. But you can actually see the human cells, because they're human. They can label them, and you can look and you can see inside all of these new fibers, there are some human cells there, but they aren't the fibers. They aren't part of it. So really, it was what the cells secreted while they were there that stimulated the resprouting. And here's another bit of evidence. On the left-hand side, you actually got some fibers that crossed, right, without any intervention. You got there is some capacity to repair there, but obviously not very much. And then with the stem cells transplanted there, you got all those more fibers made. But the other two bars are from, they took the juice that the cells were growing in, and instead of putting the cells in, they put the juice in the fibrin around there, and just the juice that the cells produced gave you a benefit. So the point is that the cells are secreting things that are stimulating your own body's capacity to regenerate itself. We're not changing the process. Our hope is that we're enhancing the innate process of healing in the body. So these are some data from the last year's data from our spinal cord injury study, and this is the percentage of patients who have gotten better. The total was on the left, and then under different categories from self-care, respiration, sphincter, mobility, extremity function, extremity trunk sensation, and pain reduction. Pain reduction is the first thing that we see in spinal cord injury. And there was a video playing at the beginning, which I had not seen. Very good job, Jonathan. Showing some spinal cord injury patients talking about their activities. This is a young man who just happened to be in the wrong place at the wrong time. He's a 23-year-old. He was in a bar having a beer with his buddies. Some crazy guy came in and started spraying bullets around, and he got one in the spine, and he was completely paralyzed. And he came to us 1 year after his paralysis, and he's a spunky young guy, and his mom videotapes him every time he has a milestone. She sends him to me. And I don't want the volume up because I think he curses in one of these because he doesn't like to be videotaped. But I do have his permission. So this is his progression. This is the first time he was mobile, and of course he's braced up and everything. But that was his first time. And then this one he's actually that's all his motion. That's his adductor muscles working. He had 0 before treatment. And this is after his first series of treatments. And then this is him on a stationary bicycle. And again, this is all him. This is his power. So anyway, I think he flips his mom off. We had to cut that one out. He's a good kid. He's a really good kid. So anyway, the treatment that we use for spinal cord injury, we use a combination of umbilical cord stem cells. We use them both intravenously because there are tissues around that need to be repaired as well. It's not just in the spinal cord. So we use them intravenously, and we also use them intrathecally or into the spinal fluid through the lumbar spine. And we use also bone marrow from the patient to stimulate. Bone marrow is really good at stimulating new blood vessel growth, and we need that new blood vessel growth to feed that new area. So that's the combination treatment that we do there. And this is a paper that we wrote. And is Juan Carlos, I didn't see that whole video. Is Juan Carlos on that video? Yes. He was from earlier? Well, this is the case, Juan Carlos Murillo, the pilot who crashed his plane and basically got everything back. We wrote that up, and this is the paper right here. And this slide basically, I guess I passed it. But anyway, so you saw Juan Carlos Murillo. So he's like the rock star of all spinal cord patients because he has all his functionality back. And he got his commercial pilot's license back, and he went from being a complete paraplegic to having all that. But Dr. Nocera talked a little bit about safety, and he did talk about mothers having this microchimerism. For every baby you've had, you actually get cells delivered to you, and these are 50% genetically distinct from you. It was once thought that mothers had a higher incidence of autoimmune disease because of this microchimerism. Because the baby cells are getting delivered to you, they thought that mothers had a higher degree. That's since been disproven in a prospective trial. But this to me is really interesting, is that the lifespan of mothers, you actually get about 1/3 of a year per kid. And it's kind of counterintuitive, right? You have to have them, then you have to raise them, and then they still call them for money, But anyway, you get 1/3 of the year per kid up till 14, and then we don't know what happens at that point. I'm sure the N value on the 14 wasn't very high, but. So when we discovered the menstrual mesenchymal cell and we wanted to do clinical trials in human beings. The FDA said, well, what we want to know for sure is that your cell, when it goes into a person who has a subclinical tumor, let's say, some people have cancer already and you're going to give it to people for heart failure, for example. What if they already have a tumor? Is it going to make it grow faster? And so they suggested that we do a trial of an animal trial of an established tumor to see if it actually enhanced the growth or not. And what we had to show was that our treatment did not enhance the growth. And what we actually found was that the left graph is the volume of the tumor. This is a glioblastoma. It's a brain tumor in a rat. And the left is the volume of the tumor untreated. The middle one is when the cells are injected intravenously, just in through the vein. And then the third one is when they were injected right into the tumor. And it didn't matter how we gave the cells, the tumors actually shrunk by 50%. So that was good news, and we got off clinical hold for those trials. So this one, this was done in Kansas, and I'm from Kansas, so I'm a big fan of K-State, although we didn't beat Oklahoma State last week. You'll find out that Dr. McKenna is an Oklahoma State fan. Anyway, so these guys basically they implanted breast cancer cells into rats, and these breast cancer cells will rapidly form a tumor, and then they'll metastasize. They'll go throughout the body, they'll go throughout the lungs, and eventually kill the animal, or they actually have to kill the animal because it's so uncomfortable having that much tumor burden. And what they did is they did the same thing. Am I done? I'm almost done. So they did the same thing. They gave either 3 injections in the vein, in the tail vein, or they gave 1 injection right into the tumor. And this is what happened. The tumors on the left, that's a control animal that didn't get treated. On the right, this animal got treated, so the tumor was completely destroyed. And then here you look at the total tumor volume in these animals with just a sham treatment, the PBS. They actually had to kill the animals. They had to, well, that's not the right term, anesthetize them. They very calmly and relaxed it. They put them in a room. Anyway, at 18 days, they had to sacrifice the animals because the tumor burden got too high. But you'll notice the other animals, it didn't matter which way they treated them, all the tumors disappeared. And by 42 days, all the tumors were gone, and they could find no tumors in these animals after even 100 days. So my summary is that, mesenchymal stem cells are anti-inflammatory. They modulate the immune system, and they stimulate repair. As we age, we have fewer and fewer of them. They work less and less well. Umbilical cord cells seem to be safe. They are able to stimulate your own stem cells' ability to regenerate. And we're doing clinical trials in Panama. Our first one will be complete in January, and we'll publish the results of that.